All right, so again, there are four types of transformations: translation or slide, reflections, rotations, and dilations. So translations are where we take an object like A, B, C, and it slides over and down or over and up. We know that this is the image, the after one. This one's called a pre-image. It's the original. This one's called the image. It's the copy. And we know that because the notations here, this says A prime, and that tells us it's a copy of the original A. In this particular case, we're saying 6 units right and 3 units down. There's two ways that could be described in notation. One is you say that X and Y is changing into X plus 6 because it's going to the right, and Y is changing from Y to Y minus 3 because it's going down. There's also something called vector notation, which is basically the same idea, but it's just pretending that there is a single vector going from B to B prime, and it's got the same information. It's going to be 6 units in a positive direction on the X and -3 units, in other words, a negative direction on the Y. So those are just two ways of writing the same thing. Any questions on using coordinate notation or vector notation to describe a translation? Okay, so here's some practice. If we're given this rule, it says that X is saying +5 and that Y is going down 3. So each of these values will go over 1, 2, 3, 4, 5 on the X and down 1, 2, 3. So if that was B, this is now B prime. This is going to go over 1, 2, 3, 4, 5, down 1, 2, 3. This would be A prime, and this is going to go over 1, 2, 3, 4, 5, down 1, 2, 3. This is C prime. And if I connect those, this shape will be the same size and the same orientation and the same angles. In other words, these two forms are congruent. Okay, here's the next one. We're given this parallelogram, it looks like, and this time it's in vector notation. So it's got these crazy little bent brackets, but it tells me that my X value is moving 1 to the left, and then my Y value is moving 7 down. 1 left, and then 1, 2, 3, 4, 5, 6, 7. Oh, that's awkward. It's going to land right on top of that Y value. This is going to go over 1, and then 1, 2, 3, 4, 5, 6, 7. That's Y prime. Over 1, 1, 2, 3, 4, 5, 6, 7. Z prime. Over 1, 1, 2, 3, 4, 5, 6, 7. That's right on top of Z. So I guess the one thing that does show us is that this angle, slope, and this angle are the same since it just slid down, which means that those two sides are parallel. Any questions on what I've done so far? Okay, so now we're stepping it up one piece. We're saying this time I'm not going to give you the coordinates in the graph. Instead, I'm going to give you the coordinates that you have to graph. So J is -4, 7. So I'm going to go 1, 2, 3, 4, first the X. 1, 2, 3, 4, 5, 6, 7. That point is J. And then K is 0 on the X, neither way, but then up 8. 1, 2, 3, 4, 5.
Mr. Erlin?
Yes.
I have a question.
Yeah.
So if we're doing it on the computer, how should we do the lines again?
Well, you can either go up into the Google Slides features, which has a line tool, or you can just leave it with the dots.
Okay, could I just leave it with the dots and just write like I did on computer? All right.
Okay, L is -1, 1, 2, 3, 4. And M is -1, 2, 3, 4, 5, up 3, 1, 2, 3. All right, so I'm going to draw in the lines because I can. And now I need to change that to apply this translation, which is moving all of them to the right 2 and down 2. So K goes 1, 2, 1, 2. So this point will be K prime. 1, 2, 1, 2. This will be L prime. 1, 2, 1, 2. This is M prime. 1, 2, 1, 2. This is J prime. And again, you'll know you did it correctly if the shape ends up congruent to the original shape. I shouldn't say you'll know you did it correctly. You have to watch out to make sure you didn't make a small mistake, and you could have made it twice, but generally that's what you find. So all three of these, what we were doing was, given the shape, apply the transformation. In other words, given the rule, figure out where the new shape is. These two are backwards. Now you're given the two shapes, and you're supposed to find out what the rule is and describe it in coordinate notation and vector notation. So the first question is, how do I know which one I start with? In other words, am I going like left and down, or am I going up and right?
Left and down.
Good, because the original ones don't have the prime marks on them, right? The ones with a prime means it's a copy. So I want to take from W to W prime. I go over 1, 2, 3, 4 on the X, 1, 2, 3 down on the Y. So if I started with XY, little arrow, and then it goes X -4, Y -3. And then for the vector notation, it's even easier. I just use those crazy little bent brackets, and I put what I've done here, -4, and what I've done here, -3. Give me a moment because I recognize that this time the Moodle version is, the Google version is a little bit harder to do. Okay, so which one's my original here? Is it the top one or the bottom one?
By chance?
Top one, right?
No, just the 4, just so I can see it. I was just gonna screenshot it just so I can write it down.
Okay.
Thank you.
Yep. And I am recording this, so I'll be able to post this and you guys can look at it there too. Okay, so which one's the original, the top or the bottom?
Top.
Good. So I'm going to go from P to P prime, or I could go Q to Q prime, or R to R prime. It doesn't matter which one I pick. I'm going to go P, so I'm going to go over 1 and then down 1, 2, 3, 4, 5, 6, 7. So going from XY to x plus 1, just moving the right, and then down 7, y minus 7. My vector notation is going to be a positive 1 and a negative 7. Any questions? Okay, so let's get some feedback in the chat. How do you feel about the translations? We did them two ways. Given the rule, apply it to a picture, and given the picture, figure out what the rule is. 5, I feel masterful in this. This is easy for me. 3, I think I'm okay with it. I did some practice last class, now a little more, and I'm getting there. 1, I'm not understanding this stuff. This is hard for me. And again, I'm looking for your engagement to keep you earning all the points you can. And this response in the chat is part of that. So if you're here, put something in the chat. Which of course means if you're not putting it in the chat, I consider you not here in class, really. Okay. The second transformation we're doing is called reflections. And this is like the mirror. When a shape is reflected over a line of reflection, the pre-image and the image will both be equal distant from the line of reflection. The reflection retains congruence, but changes the orientation. What I mean by that is if I start with a triangle, like ABC, and here's my line of reflection like a mirror, when it reflects through here, that'll be my B prime. That'll be my A prime. That'll be my C prime. And when I connect these, what I'll see is this shape was clockwise ABC. This shape will be counterclockwise A prime, B prime, C prime. It changed its orientation. It's a mirror image. Specifically, we're going to deal with a couple of them. A reflection over the y-axis, in other words, when it goes from here and flips over that way, is going to take all those x values and make them negative, and the y values stay exactly the same. On the other hand, when we want to flip over the x-axis, all the x-axis values should stay the same, and the y values go negative. And a reflection over a vertical or horizontal line can be done visually, that I'll show you in just a moment. So we start with the x-axis. We're trying to reflect this. Zoom in a little bit here. We're trying to reflect this over the x-axis. This is the x-axis. So I'm just going to find out how far away each point is. L is 2 points away from the x-axis. So we'll go to the x-axis in the shortest path and then continue on the other side to make L prime. M is only 1 away, so I'll continue that same 1 away on the other side. N is 3 away, and so I'll go 3 away. And P is 1, 2, 3, 4, 5, 6. 2, 4, 6. So I'll go up from here, 2, 4, 6. And then LP. In other words, if I were to fold my paper right on that little spot, those things should overlap if I fold it right along the x-axis. Okay, this one's asking us to fold it over the y-axis this way. So that means I'm just going to see how far away I am from the y-axis, 1, 2, 3, 4, and continue that same number on the other side. So it's a little weird that some of them go to the right and some of them go to the left. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then if I connect these, that's what we would expect to see if we folded the paper. They would land right on top of each other if we folded it along the y-axis. Any questions?
Could you show the part above the like the actual like definitions and stuff like that? Yeah, just that really fast. Thank you.
Yep. And this matches what you did last class, right?
Could I see the top one, like the one all the way to the far right?
Cool.
Thank you.
Okay, so this one's a challenge. And the reason this one's a challenge is because it's not the x-axis or the y-axis. Something else. So y equals 2 is a graph. In other words, we've done things like y equals mx plus b. So you might look at something like y equals 2x plus 5 or y equals 3x minus 7. This one is just y equals negative 2. So what would have to be happening with m, which is our slope, to make it just disappear? Well, it would have to be 0. So if we said y equals 0x minus 2, it would look just like this. And the way I graph these is I look at my y-intercept first. So I go down 2, and then I apply the slope. Up 1 or up 0 over 1. Up 0 over 1. Up 0 over 1. So what this does to make this line y equals negative 2, which is our line of reflection, it's just a horizontal line through the point y equals negative 2. Another way you can think about this is the rule that's supposed to apply to the points. So if we were to come up with a list of points that would satisfy that rule, we could have the point 1, negative 2. That's got a y value of negative 2. We could have the point 0, negative 2. We could have the point negative 3, negative 2. In other words, the x value is irrelevant. The formula doesn't deal with the x at all. The only requirement is that every single y value has to be negative 2. And that's what all these points along this line do. So I've got that. I'm trying to do a reflection across that. So my point D up here is going to go towards that new line, the line of reflection, and then the same distance on the other side. C is going to go down 1, 2, 3, 4, and then 1, 2, 3, 4. A is going to go 1, 2, 3, 1, 2, 3. 1, 2, 3, 4. 1, 2, oops, 5, 6. 1, 2, 3, 4, 5, 6. And then I'll connect those. And again, what it should look like is if I fold it along the line of reflection, these two shapes will map directly onto each other. They'll fold right on top of each other. Any questions?
How did you know how to go like how many whatever like boxes down? I'm really confused on that.
Okay. what I'm doing is I'm asking myself how far away A is from this line of reflection, right? And so I'm just looking at this little length here, and I'm counting how many Bachs it is. It's 3 units away. So then I want to do the same on the other side of the mirror. In other words, let's go back to this picture up here. If you're standing in front of a mirror and your face is like 1 foot from the mirror, and you look at your eyeballs, what you're seeing is an image that's also 1 foot away from the mirror, right? It's like it's a foot behind the mirror. So the total distance is twice as far as you're standing from the actual mirror. And if you've only got eyesight that lets you see, 15 feet because you got really bad eyesight, and you put a symbol up here that's 10 feet away from the mirror, and then it's going 10 feet back, it's really like a 20-foot distance. In fact, that's usually the way they'll test your eyesight these days if they don't use the fancy machines. They'll give you a mirror that's 10 feet away, and they'll ask if you can read it, knowing that that's really 20 feet away, which is like 20/20 vision. You can see at 20 feet what you're supposed to see at 20 feet. Okay, so now we're looking at the line of reflection. We know that because these don't have the prime marks, this is the original, or what we call the pre-image. And this is the after, or what we call the image. And in order for it to go from here over to here, where is that line of reflection going to be? Where would I fold it so that they exactly fall on top of each other?
On the y-axis.
Very good. This is on the y-axis, and if you were to fold it right there, they would match up. And you know that because it's 2 on this side and 2 on this side, and 3 on this side and 3 on this side. It's right in the middle between the relevant points. Okay, what about the line of reflection for this one? All kinds of crazy, but if I take T,
X-axis.
good. If I take T and T prime, I'm looking for these 4 points, so halfway in between is right there. If I take V prime and V, it looks like there's 8 points, so halfway in between is right there. So this x-axis is the line of reflection.
Could you show number 7 again?
Sure. And if you would please give me some feedback in the chat how you feel about reflections. Okay, good scores. Okay. So let's move on to the third one, which is rotations. A rotation is a transformation with a certain number of degrees around a fixed point called a center of rotation. When it rotates about the point 0, 0, this common center of rotation is called the origin. And a rotation retains its congruence and its orientation. So if I were to start with a triangle ABC, and I were to rotate it 90 degrees, so that I'd get A prime, B prime, C prime, what I'd see is it's still oriented in a clockwise read, A, B, then C. So they're the same size, they're congruent, and they have the same orientation. The rules for these are weird because, for example, if I'm doing a 90-degree rotation, let's do this. Would you say that this TV remote is tall or wide?
Tall.
I would agree. This looks tall and pretty thin. But if I rotate it 90 degrees, now would you call it tall or wide?
Wide.
Now it's wide, right? In other words, I've changed what used to be my Y values, the long Y values, and now I'm making them the X values. They're wide values. So what we'll expect to see is if we start with X and Y, the X and the Y will change locations. The Y now comes first and the X comes second. And then depending on which direction I go, like here it looks like we're going from quadrant 1 into quadrant 2. So for example, the point B is like 6 out and up 1, which means we go 1 and up 6. Which one had to go negative? Because we're moving left, it's the X values that went negative. So it's this part. It's the ending X values. And now, let's say that I did another 90-degree rotation. Well, that means that what used to be in the Y place moves out to the X, and what used to be in the X place moves out to the Y, and whatever's in my new X spot has to get negativized. And so at 180, they're in their right places, but they each go negative. And if I do it again, the negative X moves to the end, negative Y moves out front, but then when I negativize this, that becomes positive. So notice that both 90 degrees counterclockwise and 270 degrees counterclockwise both give us X's and Y's traded. It's only a matter of which one is negative. This one is also known as 90 degrees, clockwise. Okay, so the first step is just to kind of plot the triangles. So would you all please plot these original shapes, a triangle, a square, and a triangle, using these coordinates, and then we'll come back and do the transformations. Go. Starting from the origin, 2, 2, 6, 7. So there's my point A. Okay, so now we want to do is go 90 degrees counterclockwise. Our rule up here said that we're going to go swap the X's and Y's and change the sign of the first one. So A prime, it used to be 2, 7. So the new point will be 7, 2. And then I need to make the first one change signs. So it'll be -7, 2. The point B prime will trade places. So this will become 5, 6. And the first one will go negative. And then C is going to trade places. So instead of 4, 1, it's going to be 1, 4. And the 1 goes negative. And what that should do, basically, is if I go from here, C, back to the origin, I'd be going -1, 4 here. And if I were to draw like a little line there and a line there, those should make a right angle. That's what it means by rotating 90 degrees. So this is the point C prime. A is going to be 1, 2, 3, 4, 5, 6, 7, and then up 2. And B is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And what that should look like, if I did it correctly, is that if I took this blue one and I rotated it 90 degrees, the paper, it'll end up pointing this way, right where the red one is. So if I spin the paper 90 degrees, it ends up pointing kind of off to the left like that, which is where the red one is. Okay, so let's do the same thing here. Now we're doing 180 degrees. So that's the one where we're just going to get -x, -y. I guess it would have been helpful to write this here. So I'm going to take the point P and I leave them in the right places and I just make them negatives. So if the original was 2, 6, I'm just going to go -2, -6. Q was originally 6, 5. So I'm just going to make it -6, -5. R was originally 5, 1. I'm going to make it -5, -1. S was originally 1, 2. I'm going to make it -1, -2. So the P is going to go 1, 2, 1, 2, 3, 4, 5, 6. There's P prime. Q is going to be 1, 2, 3, 4, 5, 6 negative. 1, 2, 3, 4, 5 negative. So there's Q prime. 1, 2, 3, 4, 5. Down 1. That's R prime. And S is -1, -2. And then I'll just connect those points. Any questions on doing these rotations? How do they seem to you?
How do you know whether it's going to be like -x, -y? Because in the first one for me, like I'm not sure why it would be -y, x. Because I don't know if I wrote it wrong, but on the origins thing, oh okay, I did write it wrong. Because for me it was just y, x. It wasn't -y, x for the 90 degrees.
Yeah, this is the rule. So you got to have those written down really carefully. Can you give me some feedback on how you feel about rotations now, please? 5, these are easy. I get the rule and I just plug it in. 3, it's hard keeping track of them. It takes a lot of detail. 1, it's very confusing. I agree that rotations visually are harder, But I find if you just do the rotations with the numbers really carefully, just making the transition, it's much easier. Okay, why don't you try this one yourself now, please? Notice that it says 90 degrees clockwise, which is this bottom one. It's the same as 270 degrees counterclockwise. So because it's 90 clockwise, that's the same as 270 counterclockwise. So that's my rule. They're trading places. So instead of an 1, 5, I want them to be in the opposite places, 5, 1. And the second one has to get a negative to it. So then M, instead of being 3, 8, will be 8, 3. And the second one, the new Y value, has to get a negative. Instead of 8, 1, it's going to be 1, 8. And the second one needs a negative. And then I can plot that. So 1, 2, 3, 4, 5, negative 1, that's L prime. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, that's M prime. And 1, 1, 2, 3, 4, 5, 6, 7, 8. That's N prime. Okay. Last page is dilations. And these are the only ones that are non-rigid. Rigid means can't change, right? Sometimes people are called rigid because they don't adjust well. So what we're talking about here is the ones where they can't be shrunken or stretched or made bigger or smaller. So rigid ones are where the size stays the same. Dilations are the only ones where the size can change. It's actually a smaller or a bigger version of it. So a dilation is an enlargement should be an enlargement or reduction of a figure with respect to a fixed point called the center of dilation. A dilation is an example of a non-rigid transformation. In that it does not preserve congruency. They don't end up the same size. A dilation produces similar figures. And that word similar is really important to us. That's going to be the core of our next unit that we'll do when we get back from President's Week break. So when we're dealing with these things, we're going to have something called a scale factor, which is how much it shrinks or grows. And we often use a character K for that. And when we have K be greater than 1, it really should be absolute value. Then it's an enlargement. And when the absolute value of K is less than 1, then it's a reduction. And what's great about these is the rule is really easy. If you start off with X's and Y's, all the rule says is whatever that K was, you just multiply both the X and the Y by it. just distribute it across them. Okay, so let's take a look at these. Well, we've got some figures to draw first, so we may as well do the originals. RST with R of negative 5, 1. 1, 2, 3, 4, 5, 1. So there's R. S is negative 3, 4. 1, 2, 3, 4. And T is 2, negative 1. So this is my starting figure. And let's just do all the starting ones first, then it'll be easier. So W is negative 4, 1, 2, 3, 4, of 8. 1, 2, 3, 4, 5, 6, 7, 8. That's W. And then 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is X. And then negative 2, 1, 2, 3, 4, 5, 6, 7, 8. This one is a square with 0, 0. That's D. 1, 2, 1, 2, 3, 4. That's E. 3, 4, 5, 6. 2. That's F. 1, 2, 3. 1, 2, 3, 4. Down to G. Give you all a moment to catch up on that. So now let's apply the transformation. What we said with the dilation is you just multiply this K, scale factor, times all the components. So instead of negative 5, 1, we'd multiply it 2 times negative 5, so negative 10, and then instead of 1, it's going to be 2. For S, instead of a negative 3, 4, it's going to be times 2, so negative 6, comma 8. T is going to be 4, negative 2. And
I have a
again,
question.
yeah,
So how do we know it's going to be negative in the front? Is this the same rule as the last ones?
each of these pages is going to have different rules. This page's rule, you just multiply the K that you're given, which is the scale factor, times the X and the Y. They don't change places. You don't put negatives in front of them. It's just exactly as it is. So
Okay.
it gave us negative 5, comma 1. We just multiplied those both times 2. Negative 10, comma 2. Okay, so this one says a scale factor is 1/4. So if I multiply 1/4 times negative 4, that's going to give me negative 1. If I multiply 1/4 times 8, that's going to give me a 2. If I do 1/4 times 10, that's going to give me 2.5. 1/4 times 0 is going to give me 0. 1/4 times negative 2 is negative 1/2. 1/4 times negative 8 is going to be negative 2. These last ones have some fraction work to do, but interestingly, 0, 0 times 5/2 doesn't change. So that's still going to be 0, 0. 5/2 times 2. that's really like 2 over 1. So the 2's will cancel and I'll just get a 5. 5 halves times 4 is 20 over 2, which is 10. 5 halves times 6 is going to be 30 over 2, which is 15. 5 halves times 2 is 5. 5 halves times 4 is 20 over 2, which is 10. And 5 halves times negative 2 is negative 5. And if that was a little fast for you, remember, you get to use calculators for this stuff, so just do it carefully. And now we'll just plot the points. So we're going to plot negative 10, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There goes 10, and then up 2. So that's R prime. And then S is going to be 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5, 6, 7, 8. And then 4, 1, 2, 3, 4, down 2. That shape should have all the dimensions exactly twice as big because we had a scale factor of 2. So it's an enlargement, it's getting bigger. So next one, so W is going to go over 1 left and then 2 up. W prime. 2.5 over, and then sitting right there, so that's X prime, and then negative 1/2 and negative 2 right there, and that's going to be Y prime. And not surprisingly, this one's smaller. With a scale factor of 1/4, that should be a reduction. Last one, 0, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's E prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5. There's F prime. Shouldn't have marked that. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. There's G prime. And now if I connect all these, it should make a bigger shape, about 2.5 times as big, because 5 over 2 is about 2.5. Any questions? Okay. For these last ones, it's giving us a slightly different spin on it. It's saying if A prime, the image, is -10, -8, after a dilation centered at the origin with a scale factor of 2, what are the coordinates of the original A? We know that xy goes to kx, ky, right? This is the image. If this is A, this is A prime. And they're telling us that the first part, kx, equals -10, and they're telling us that k is 2. So 2x equals -10, which means x equals -5. And then they also told us that ky would equal -8. And we know that k is equal to 2. So if 2 times y is -8, then y is -4. So the original point A would be -5, -4. Same idea for 18. So whatever the original point P is, x, y, P prime is going to be kx, ky. And they're telling us that k is 1/3. So we know that the result, the image, is supposed to be -2. We know that our k is 1/3. How do I solve that though? If I've got 1/3 x equals -2, what do I do to solve that?
Wouldn't you like divide 2, -2 and 1/3, or 1/3 and -2?
You could divide -2 by 1/3. People often have a hard time dividing by fractions. So the other thing we could do is we could multiply it by 3, because that'll cancel out the 1/3. And that's going to leave us 1x over here and -6 here. Do the same thing with the y. ky has got to be 5. If we know that k is 1/3, then we got to multiply both sides by 3 to make that work. That'll leave us with y equals 15. So the original point, P, is going to be -6, 15. Okay, last piece. How do you feel about these dilations? 5, these are easy. I just distribute the scale factor across them and plot them. 3, there's a lot of rules that have come up, and it's a little hard to keep track of which ones are which. But if I have notes that help me clarify, I should be all right. 1, these dilations are confusing. Okay, so that's all I've got for today. You're submitting this is your homework for tonight. If you want to look at last night's work, that had some more practice, and maybe that would be good for you to understand now that we've done this very carefully a second time. I also need to clarify that there's still a lot of people who haven't taken the unit tests. And next week when we go away on vacation, that's all going to forget. I see some good work on the polygons. We're Rashid did a great job. Tomas did a great job. Oliver did a great job. Sasha did a great job. Nancy did a great job. Marcus did a great job. Eden Daniela got him done. Could go a little higher, but that's all good. Lucia did a great job. Anderson's got something in there. Natalia's got something in there. So on the polygon side, we're getting there. The quadrilateral side, we got a lot of people who haven't tried them. Again, Rashid and Sasha and Nancy and Daniela and Lucia and Mark and Natalia have done it. But I think you want to try that again, get some higher points. And the rest of you haven't even done it yet. So I'm purposefully not giving you homework tonight other than just to post this. Please, please, please get your Moodle tests done. If you wait until after break or wait until we go on break and then you're trying to do it yourself over break, you'll forget it. Okay, so you're welcome to stay if you have any questions. Otherwise, fly and be free.
Thank you. Mr.
Thank
Erlin, you said how many tests are we supposed to do in total? There's the polygon, quadrilateral, that one, and then there's the unit test, or is those two the unit test?
When you look into Moodle, what you should see is under the quadrilateral unit thing, unit 7, there should be part 1 test, it's polygons, and part 2 test, it's quadrilaterals. I broke it up into 2 parts.
Oh,
And
okay.
you've
Okay.
What
taken,
does the second part do?
they're both, we should have them done now at this point, but you know, do what you got to do, get them done. Nancy, I show that, oh, you actually do have an 80 on the other one. Yeah, so you've got a 100% on the first one, which is awesome, and an 82 on the second one, which is also very good. Oh, it's not getting me the readings. It's supposed to have coloring for me. Sorry about that. Let me fix that coloring. Seven. So,
Also, Mr. Erlin, I forgot my Big Ideas password. Is there a way you can get that for me, please?
sort of. You can go into Big Ideas and click on Lost Password, and it will send me a temporary password, and I can happily give you that. You gotta do that first.
Okay, thank you, Mr. Erlin.
You want to hang out here, get that done now?
I can't. Okay, yeah, I should. Let me see. Oh, wait. I think I wrote it down. Let me see. I did. Okay, never mind, Mr. Erlin. I wrote it down in my notebook. I forgot to look in there.
Okay,
Okay, thank you. Have a nice day.
you too. What's up, gentlemen? Gavin, Mark, you guys need help?